Welcome to another video from Chapter 6, which is Inequalities. Today's video is part 1.5. So this is the video that you should be watching between parts 1 and 2. It's just a continuation of part 1, so it's going to be a little bit of solving. Today we're going to solve special inequalities. So sometimes it's not possible to solve an inequality, or sometimes you're going to get a special solution. So today we're going to do some examples. It says solve and then it gives an inequality. So I'm going to subtract 2x. Okay, and then I notice my x's cancel. And I have negative 4 is less than 7. I need to ask myself, is this true? Yes, this is always true. Okay, because this is always true, your answer is all real solutions. Now if I asked you to graph this on a number line, just throw some numbers on here. All real solutions means I'm going to shade everything on the number line. So any x on that number line is a solution to this inequality. Let's try another one. Okay, so I'm going to solve this like normal. I'm going to distribute on the left side, so I have 3x minus 12. On the right side, I'm going to combine like terms. So x and 2x is 3x, and then plus 5. I'm going to subtract 3x from both sides. Those x's cancel, and I have negative 12 is greater than 5. Now I need to ask myself, is this true? Is negative 12 greater than 5? No, this is false. Anytime you have a statement that's false, there's no solution. So there's not a single x value that will make that inequality true. If you were asked to graph it, there's nothing to graph. There's no solution. So those are the main two examples from this video. We're going to do 3 more, and then you can move on to video 2. Okay, so here's the next one. Again, I'm going to solve like normal. X subtract 7x is negative 6x plus 15. Distributing the 3, I have 12 minus 6x. I want to get those x's together, so I'm going to add 6x to both sides. Those cancel, and I have 15 is less than 12. Now, when is this true? Well, 15 is never less than 12. This is always going to be a false statement. False statement means I have no solution. There's not a single x value that will make that inequality true. Okay, here's an example for you to try. So pause the video and try this example on your paper on your own. When you are finished, come back and we will go over it. Okay, let's see how we did. First thing is you should have distributed that 3 on the right side, so you get 3x plus 3. Now I want to get my x's together, so I'm going to subtract 3x from both sides. My x's cancel, and I have 5 is greater than 3. Now, is this a true or a false statement? Well, we should know that this is a true statement. 5 is always greater than 3. Because this is true, my answer is all real numbers. So any real number is a solution. If you were asked to graph this on a number line, I'm just picking random numbers, you would shade everything. Any number on the number line is the solution to this inequality. Okay, we have one more example and then you can move on to the next video. Here's example number 5. So it says 2x plus 5 is greater than x plus 5. So I'm going to subtract x from both sides. Those x's cancel. 2x minus x is x. So I have x plus 5 is greater than 5. We're going to subtract 5 from both sides. Those 5's cancel. Those 5's cancel. Sometimes students at this point want to say, okay, everything canceled, no solution, or all real numbers. No. These 5's cancel. These 5's become a 0. So I end up with x is greater than 0. So I just wanted to show you to be careful in cases like this. If your numbers cancel and you're left with an x, then there is a solution. That solution is 0. Okay, so this was a quick video. If you have any questions, please go back and re-watch the video or ask Ms. Bunn or Mr. Teresi. If you are ready at this point, you can move on to part 2.